Good morning and welcome to the session 3 on EDU-ROBO. Session 2 we have discussed about what is this activity based learning and why it is important. We have briefed 3 levels, which is level 1 applications, level 2 applications and level 3 applications. Level 1 applications doesn't require any background, irrespective of any branch, or even science students can do that. However, level 2 requires a little bit of logical thinking because we talk about the algorithms. Level 3 is about the technology, so we need to have some background about the technology. Alright, so this is all about level 1. We are still in level 1. So today's session we will discuss about the software and hardware in the context of real-time systems. What are the real-time systems and how they are different from desktop systems? That is the topic. And at the end of the session, we will discuss about the real-time system which we have designed, which you will be using extensively in order to complete all these 3 levels, which is we made it compatible to the Arduino compiler, which is a freeware. So we will discuss about the basics of it. All right, so we are organizing this event at 2 places. One is in Mumbai, Bhavan's campus, Sardar Patel Institute of Technology Product Development Center. Other is at Nandigama, Andhra Pradesh, and also the skill development center is at Vellanki, which is nearer to the Nandigama, Andhra Pradesh. Okay, so in this session, we will be talking about what is automation and how automation has now lead to smart machines and their applications. Why we named EDU-ROBO, right? I mean, where this robo comes into picture that we need to understand. So that's about the first 3 topics. Then I was telling about desktop systems versus real-time systems, right? Similarly, the operating system and their CPUs, compilers, and the real-timeness. What do you mean by real-time here? What is emulation? What is simulation? What is real-time debugging? That's another interesting topic. And which language we use, right? In it's the entire journey, we will be using what is called embedded C. So let's discuss about how this C is different from the C program which we write it in the computers. And finally about the compiler which we are using, that is Arduino compiler. A lot of information is there available online about the Arduino compilers. But we will be talking about our system, right? So we have designed our own system. So naturally, whatever is the components which are populated on the board is a unique, right? It's not there in the market. We have designed as per our requirements for our educational purpose. So then we will see our board when we connect it to the computer, how it recognizes and how to write a simple program. So this is the session, right? Or I would say first session. Though we had 2 sessions, but this session we are starting very specific to our board. Yeah, or you can say our tutorials. First tutorial is about how to write a simple program using a compiler and then transfer the program from the computer to the board. Let's see the entire journey. Automation is not new. Today people are talking about industry 4.0. In the sense, the industry also has witnessed four generations, right? Industry 1, 2, 3, 4. So what way, I mean, they are evolved, in what sense, right? Initial stage, right, when there was no electricity, right, and then naturally this entire, whether it is a machines or it's a transport, whatever, they were all on either burning the coal or converting the energy from thermal energy to steam energy, and steam based trains or vehicles or machines and so on. So that's how they used to do this automation. Then the due to invention of this electricity, we have motors and drives which are working on based on the amount of current passing through those coils, right? The coil means in turn it will generate some magnetic field, which there will be a corresponding displacement, we called as a motors. Then no, this large scale manufacturing came into picture, production, automation. This fourth generation, what we are talking about is smartness, right? Today we are talking about sixth sense, artificial intelligence, a neural network, fuzzy logic, machine learning, right? Lot of mathematics we wish to put them in the devices or the machines. All right, so as you can see, right from a simple crushing machine, roadside, we might have noticed, right? A simple sugar cane crushing machine, where you can extract the juice without having a motor also. Sometimes you might have noticed where there is no electricity, people are using that handmade crushing machines, or the bore wells you might have seen in rural places where there is no electricity, right? Uh, you might have seen the hand pumps where you can uh, uh, pump the water from the underground. Yes, these are all small automations, but then due to invention of these motors, we have slightly started adding even the crushing machine, sugarcane machines, grinders, mixies, washing machines. They're all having a small electrical motor where electrical energy is converted into some mechanical energy or vice versa, right? Maybe a turbine or a windmill, there the wind energy is converted into electrical energy. So these are all the machines, right? So as you can see, as I have listed, every day to day life, we see a lot of machines which are in even the healthcare sector and the gyms, or I was telling about vending machines, packing machines, and so on. All right, so a machine may be a pure mechanical, or a machine may be a, like, no, our ceiling machine, a ceiling fan, which is a motor, right? Is a pure electrical system, or maybe a grinders, right? The mixers. There's a combination of mechanical, because there are gears are involved, right? So naturally, there's a combination of mechanical and electrical, or maybe, right, some smartness in the system, like washing machine. It is mechanical, electrical, as well as electronics, because there is a some programmable devices. It's not only gears, it's not only motor, but there's also a speed control of that motor, or changing the direction of the motor, changing the spin cycles, changing the detergent, changing the water temperature, and so on. So naturally it is electronics, mechanical and electrical, right? And similarly the elevators. But if you see the ATM machine where it's not only, it's a mechanical or electrical and electronics, but it's also a computer. When we say computer, we have, right, that feeling. It has a keyboard, it has a monitor, and it has an operating system, and application programs are running. But that's a reality, right? ATM machine has all these features, but it also has a motor inbuilt, gears inbuilt. You can, as soon as the uh, your account details are entered, it opens the door, it counts the notes, it will, right, it will flush it out, whatever is the amount you have entered. So I mean, so it's a electrical, mechanical, electronics and computer based system. I hope now you can understand that though it's a machine, right, these are all the machines, but it depends uh, what extent this automation is done. Now industry 4.0, right, that is the current generation machines, we are talking about smart machines, right? Even when you purchase a refrigerator or air conditioner or a TV or a mobile phone, we say smart, right? You want smartphone, smart TV, or smart air conditioner, and so on. So what is that smart? Where is this smartness comes into picture? Let's say tomorrow you want to manufacture some product, right? That you want to say the product is smart. So where this smartness comes into picture, right? I mean, I have shown you a couple of machines. Can we say your fan is smart? Can you say your crushing machine is smart? Your grinder is smart? We don't say they are smart. But today, when you look at these devices, right, air conditioners, refrigerators, a non-smart AC is cheaper. A smart AC is costing at least 5 to 10,000 rupees extra. So we are paying for something else. That smartness comes because of what? Is it because of the sensors, right? It has the ability to sense. Or is it because of the quality of output? Or is it because of the user friendliness? Okay. So what is that smart? When do you say it is smart? Okay. Maybe you can compare yourself that you have a TV, normal TV versus smart TV, normal refrigerator versus smart refrigerator, normal air conditioner versus inverter based air conditioner, traditional four-wheeler versus this driverless cars or drones, pilotless drones, nor conventional watches versus the smart watches. Compare, right? I mean, what is that feature where people are paying for that? Though the basic principle is same. A watch is supposed to show time. A mobile is supposed to make a call. A refrigerator is supposed to maintain some temperature of those food items. Air conditioner is supposed to maintain the room temperature. A four-wheeler is supposed to carry your belongings, whatever. But these basic features are same, right? I mean, whether it is a smart or not smart, they are there. But then there are certain features where you are paying a huge amount. A mobile is costing you 900 rupees, but a smart mobile phone is starting from, let's say, 3000 to a lakh of rupees. So why people are paying that additional 90,900 rupees, or maybe beyond that, even 1.5 lakhs also phones are costing you. What for? A four-wheeler is supposed to be 2.5 lakhs, 3 lakhs, but people are paying smart vehicles, maybe 50 lakhs, 1 crore, 2 crores, and so on. A TV, a LCD TV, you will get it in 10,000 rupees, but people are paying a smart TV 1 lakh, 1.5 lakhs. Even a classroom whiteboard is now replaced by a smart whiteboard, which is costing more than a lakh of rupees. So I hope you can understand what it's not just automation. Automation is already done in Industry 3.0. Industry 4.0 is all about smartness, smart devices, smart machines. So there is no great invention here. TVs are still there, ACs are still there, four-wheelers are still there, devices are still there. They are there. It's not that all of a sudden you have come up with some great products. Absolutely, they are still the same products, but slightly adding some additional features, that smartness, people are charging huge amount. Anyhow, so that's the business. So that is why I'm saying that why it is important every one of you to learn the software hardware partition, and most importantly the mathematics. Whatever we study mathematics 7th standard onwards, the maths, the physics, the chemistry, whatever we are studying, why they are so important? Because they are the basics. Today these branches, when we are talking, right, AI, ML, data analytics and all, basically they're all coming from science, right? These are all science subjects. So those science subjects now has become a verticals, 4 years vertical, beyond that even masters and PhD programs. So the purpose of this EDU-ROBO program is to realize right from the school education itself, the subjects, whatever we are studying, physics, chemistry, maths, why they are so important. Whatever we are studying, one need to realize their applications. They are not just a passing subjects or a scoring subjects. They are the applications of in our day-to-day life. So generally we have a feeling that a robot means it looks like a human. It should have two legs, two hands, two eyes, two ears, one head, right? That's a general feeling. It should talk, it should walk, and so on, right? But then, in reality, right? If by any chance, lot of videos are there online. Maybe I will share you a few videos. You can look at the features. Or by any chance, if you go to any nearby industry, generally, those automobile sector today is completely uh, manufacturing is done by robots. Aviation is also those Boeing and all is manufactured by robots. These market, right, these warehouses, the dispatching the material is all done by robots. These are the easiest way one can go and visit. You will surprised to see that you don't find any, though they called robots, but then you don't see them like no two legs, two hands, two eyes, one head, two ears, can speak. No, these features won't be there in robots. Okay, so let me put you in a different way. When you say robot, right? Can I say my washing machine is robot? Is my air conditioner is robot? Is my refrigerator is robot? My four-wheeler is robot? We cannot call them as a robots. But at the same time, a robot consists of what? Motors, controllers, some peripherals, and some whatever may be the nature of the job, accordingly the body is made. But both, it is also having some mechanical movements and so on, but then we don't call them as a robot. So let me put this way. When I am saying robot, then it is a reconfigurable system, multifunctional system. Not necessarily it should looks like human, but then it has the ability to define, redo the things. Let's say, for example, you have a machine which is doing the job of fixing the things, right? It is fixing some motors or some tires or whatever, no? Like that's what you notice in the automobile sector. Tomorrow, the same machine, by changing some few end points, I will put that machine for drilling, or by changing those end joints, I will put that machine for welding. By changing some few joints, I will make them for painting, and so on. So it is multifunctional, reprogrammable, reconfigurable. That's where I would say that it is, for example, your washing machine, you cannot do it for some other job. Even you cannot even change the parts. You cannot change the program. One task, one function, one job. So this is my perception that no, if you have any system which has the ability to change its functionality, reprogrammable, then I would say yes, it's a robot. Like humans, right? We are not doing only one task throughout the day, right? I mean, we are doing multiple things. So if those kind of operations, if you are getting it done by a machine, then I would say, yeah, it's a robot. Not necessarily it looks like human being. It may be just one hand. Maybe one hand is doing multiple things, is also called as a robot. I will show you some few videos how a industrial robots looks like. So I have listed few points. It should work indigenously, no human intervention, and it has the ability, at least some ability to think, or that's what I was saying, smartness. That means some feedback, right? We are having this smartness is because of our feedback system, right? Our brain, before taking any decision, it is taking the feedback, right? I mean, through my nose, my ears, my eyes, my hands touch sensors, right? So we have several organs where sensors, before doing any task, the brain is sensing and then accordingly taking the decision. So if that kind of feedback, the inputs, if I am giving to the system, and then if the system is taking, thinking, analyzing, predicting, correcting, if these things are happening, then definitely I will say it is smart. I don't say robot, but at least I will say smart. My mobile is smart, my AC is smart, my TV is smart, my refrigerator is smart, my car is smart, and so on. So it's a smart because of its ability to behave, ability to think. Then yes, it's smart. But if it is a multifunctional, and if it is doing these things without any human intervention, then we can say yes, it's a robot, because it's not doing one task, it can do multiple tasks, multiple functions by slightly reconfiguring the system. All right, so, but at the same time, we also have some applications, domestic applications, or some commercial applications where a robot looks like human structure, human physical structure, like speaking, the way we speak natural language. We wish this robot also should speak the way we can sense, right? Whatever the sensors we are having, include image, we wish that the system should have. So, including the physical structure, right? Two legs, and those two legs also not rolling, walking, lifting, running. So if those things, if we can incorporate whatever equivalent of a human being, then we call them as a humanoids. People are developing such type of automation robots also, but definitely they are not meant for manufacturing sector. They are for either domestic or maybe some uh, some of the industrial applications. All right, so that's my perception about when do we say robot and which type of things we say automation. And I also said what's the difference between smart devices and otherwise also they're all applications where uh, we would say application specific programs. I will be sharing few videos, 8 videos. I would like every one of you should go through the video and identify. I will put you some questions. You should identify from those videos. Those videos consist of the robots, or you can say automation. Some of them are smart devices. You should be able to classify which robot is an industrial robot, which robots is a domestic or household robots, which is a medical robot. There are robots for service sector. Some of the countries are using for defense military applications. Entertainment, people started using, particularly in this COVID situation also, people started using this kind of robots, because even to deliver the medicines, right? I mean, since this virus is uh, is supposed to be, right, I mean, problematic, right, in spite of wearing lot of protections, there are issues. So people prefer to treat the, if not treatment, but at least delivering the medicines to the patient. So some of the hospitals started using the robots for our entertainment purpose because the patients are in isolated areas. Or maybe some of these food sector restaurants also people started using these entertainment robots. Okay. We all know robots are also sent to Mars or Moon and space, called space robots, to explore the environmental conditions of those places. And robots are also used underwater, underground, and so on. And some robots are also getting manufactured for hobby purposes, right? For gaming and all. So I have some questions I want you to identify by looking at these videos. How do you classify them, right? Because the kind of sensors, the kind of structure, right? The kind of motions, the kind of intelligence, when they are fabricating into the system, there is a difference. A industrial robot, the kind of material which is used is different, because if a robot is welding, drilling, cutting, then the kind of body structure required for an industrial robot is entirely different as compared to a robot which is used for entertainment purpose. For entertainment purpose, the robot should looks like, right, like a human body, not rough surface or whatever, right? I mean, we should feel like touching the robot, not like no feeling threatened, right? You don't like to look at like a skeleton, right? I mean, for entertainment robot, but in industrial robot, it's okay. But what is important is the body, the metal, the material which is used should withstand the higher temperatures, or maybe the kind of environment, poisonous gases, whatever. Absolutely no corrosion or no reaction. So it's a different, right? So though we say robot, whatever the features I said, multifunctionality, ability to think, but still they are classified based on the applications. Okay, so after watching the videos, at least in this session, I want you to answer, what is that robot? Is there any multifunctionality in it? And in which field it belongs to? It's a mechanical, electrical, electronics, computer, AI, etc. And they identify the parts, right? What kind of motion it is? Is it say electrical, hydraulic, pneumatic? And does it have any electronic components? Is there any sensors, software, hardware? How many sensors are there? What type of sensors are they? How many of them are inputs? How many of them are outputs? Is it thinking? Does it have the ability to think? Does it have the ability to learn? Is it learning? Is it an intelligent system? Right? Try to analyze what is that knowledge and intelligence. When do you say the system is knowledge, is having a knowledge? When do you say the system is having intelligence? Is there any intelligent system? Humans are intelligent. Is the machine is intelligent? Or it's only having a knowledge? So what is the difference between an intelligent system and a knowledge system? What is the percentage of smartness it is having? How will you compare the percentage? With whom you will compare? and its application. So I want you to at least, when I am saying Industry 4.0, when I am saying AI, ML, and analytics and so on, and if these things, it's not in computers, please remember, these are all part of the real-time systems. So we should be able to classify them. Is it a simple automation, or it's a smart device, or it's a robot? And if it is a robot, then what extent it has these following features. All right, so uh, that's the end of my session today. After going through these videos, I want you to answer these questions. Then we will talk about, we will focus on the system which we have designed, EDU-ROBO. I know these are not the features which is having, but slowly we should learn. It's all about for learning. Whatever we are talking, mechanical, electrical, or software, hardware, sensors, knowledge or intelligence, can we incorporate these things into our system, is what is our complete journey of these three levels. Okay.